Welcome to Algebra Online. Today we're going to take a look at the shape of data. So when we look at the shape of data, we're wondering, is our data normal? Here's our normal Curvosaurus, and if our data looks like this, it's considered normal. When we refer to the shape of data distributions, we could be looking at a box plot, a histogram, a dot plot, and we're looking at these four items: shape, outliers, center, and spread. So if we look down at the graphs here, there's data that's skewed to the left. Remember that the skew refers to where the tail is, and it also refers to where the mean is. So the mean has kind of been dragged to the left here. When we have a right skew, the mean has been dragged to the right. And if it's symmetric, the mean, median, and mode are all in the middle. Let's take a closer look at the SOX acronym. The first S stands for shape. Is it skewed? Is there symmetry? Where's the mode? Here we have a negative skew, because if I were to kind of trace this along, I could tell that this has a longer tail to the left. The mean also has probably been dragged somewhere here. No skew is completely symmetrical, and the mean, median, and mode would all be the same. And positive skew, if I trace this has a right skew or positive skew because the tail is longer to the right. Outliers. Are there outliers? We would see maybe a little dot down here or something if there were outliers. Center. Are the measures of center the same? So that's mean, median, and mode. And when the graph is symmetrical or the data is symmetrical, we see that the mean, median, mode are all in the middle. When there is a positive skew, the mean has been dragged to the right. The median could be somewhere else, but the mode would be the highest peak. And then spread, how spread out is the data? So we're kind of looking at the range here. This range just goes from 3 to 8, whereas this goes from 1 to 10. So this has a larger spread. And those are basically the four items we're looking at when we talk about the shape of data. So we are going to take a closer look at standard deviations in another video, but that gives you a little introduction. Basically what the video was saying was, if we have the peak of our curve, one standard deviation represents 68% of the population. So it's kind of like the above and below count as one. Again, we took 4 inches below and 4 inches above, and that's considered one whole standard deviation. Then 2 standard deviations above and below would represent 95% of the total population. And 3 standard deviations get us to 99. Now there was a little bit of notation that you might see when you're dealing with this, either on a calculator or on a homework sheet or something. This is the Greek letter mu, and that is the mean of the population. So if you're doing things for the total population, you would use mu to represent the mean, and lowercase sigma, which is also a Greek letter for the population. X bar is the mean of the sample. So if we're doing a sample and not the entire population, that's considered X bar, and S is the standard deviation of the sample. So we'll talk more about standard deviation in another video, but that's all for today. Have a great day.